Hi guys, this is Saurav here and welcome to another JEE Advanced Aspire series for the JEE Advanced 2019. In this session, we would be covering equilibrium, which comprises of both ionic and chemical equilibrium. And though we would not be able to take as many questions as I would want to, however, we would try to take most critical questions which bowl out a number of students, primarily from the areas of I'd say common ion effect, buffers, salt hydrolysis, a bit of solubility product. The point is chemical equilibrium and ionic equilibrium are not that very dreaded as perceived by students, क्योंकि बहुत सारे connections दोनों के बीच में हैं जो कि related हैं. However, people try to learn it in a way that they try to use a formula and apply it everywhere. So chemistry में इतना easy नहीं है. You have to apply your mind to think that whether I should be going forward with this formula or whether I should first try to identify what is the missing link. Identifying the missing link is more important than identifying the right formula to use for a particular question. So without wasting any more time, let's start with today's session, and I hope you like this today's session because we have chosen questions which are primarily are the standard type of questions for JEE Advanced, like multi-option correct question, single option correct question, and integer type question. So let's see what are these questions and how to tackle them if such questions do come in the examination. So our first question for today is this. The first question for today is this one, which is a multi-option correct question. Which of the following statement is or are correct? pH of 10 raised to minus 8 molar HCl is 8, which is obviously incorrect, because I have already discussed this thing in past in one of my earlier sessions. Also, you know this thing, guys, that an acid cannot be diluted to such an extent that it becomes a base. That is what is happening. An acid range is 0 to 7 or just before 7, and you're diluting it because 10 raised to minus 8 more, that's extreme dilution. That means we are diluting it to such an extent that it becomes a base. That is not possible. When you account for the amount of H plus that comes from water, the pH turns out to be somewhere close to 6.9. I think they have solved this question in a standard format, and we know this result. This is known to, I guess, most of you guys. If we take into account just a moment, if we take into account the relation that H plus contribution should come from water, this statement turns out to be incorrect. The conjugate base of H2PO4 minus is HPO4 2 minus. This is obviously correct because a conjugate acid and a base, like this is, if this is an acid, this is an anion from a polyprotic acid which is H3PO4. If it loses a proton, it will form this. So they should be related to each other with a difference of just one H plus ion, and so this is a correct statement. The pH of 0.1 molar NaCl aqueous solution is half of pKw. How do we know this? Now, it does not matter that whatever is the amount of NaCl which is given. NaCl is a salt of strong acid and strong base, and no matter to whatever amount of NaCl you put this thing in water, the extent of hydrolysis of this is negligible. The extent of hydrolysis of this is negligible, and because of that, the pH of the solution will always be equal to 7. So this will also be correct. A similar situation can exist for Na2SO4, where the pH for any amount of Na2SO4 that you take will always be equal to 7. So half of pKw, Kw is 10 raised to minus 14, pKw is 14. So half of that value is 7. That's a correct statement. The last statement is ionization of water increases with decrease in temperature. Ionization of water increases with decrease in temperature. It is an incorrect statement because ionization, we know for a fact, that is bond dissociation. Dissociation will increase if the thermal energy increases, if the bond vibration increases, and that will be increased only when the temperature is increased. So the right answer to this question is B and C. B and C. Okay, बहुत ध्यान से क्वेश्चन सॉल्व कीजिए, आराम से सॉल्व कीजिए. You do not have to rush through all the questions. You do not have to solve all 20 questions that come in an examination, or whatever 18 will come in the examination in a paper. Try to target 14 questions. 10 to 14 questions should be sufficient to get you a rank you want. Okay, so 14 questions is very good. 14 क्वेश्चन सॉल्व करने के लिए यू डू नॉट हैव टू लाइक रश थ्रू द पेपर. लेट्स गो ऑन टू द नेक्स्ट क्वेश्चन. The next question is this. 50 ml of a solution containing 10 raised to minus 3 molar Ag plus is mixed with 50 ml of 0.1 molar HCl solution. How many Ag plus remain? How much Ag plus, the concentration of Ag plus that remains in the solution? KSP is 10 raised to minus 10. इसका मतलब ये होता है कि if I try to combine Ag plus with Cl minus, almost all Ag plus will undergo precipitation because the formation of AgCl is highly favored. Okay, KSP is dissociation of AgCl. Backward process will be in the order of 10 raised to 10, and because of that the combination of Ag plus and Cl minus will be highly favored. How should we solve this question? The method to solve this question is very simple. So what you need to do is you first need to calculate what is the amount of Ag plus which is present within the solution after you add two things. That means आपने 50 ml इसका add किया, 50 ml इसका add किया. What is the amount of Ag plus? So let's try to calculate the concentration of Ag plus after you mix this. So you have 10 raised to minus 3 moles and 50 ml plus 50 ml, that turns out to be 100 ml, which is nothing but 0.1 liters. So amount of Ag plus present when a mixture of these two solutions is taken is 10 raised to minus 2 m. Okay, let's do it for Cl minus as well. 50 ml of 0.1 molar concentration, 50 ml of 0.1, that means 5 millimoles of HCl minus is present. Milliliters times molarity is millimoles, so 5 millimoles is there. 5 times 10 raised to minus 3 moles present in 0.1. So this is equal to 5 times 10 raised to minus 2, that is 0.05 m. Clear? So our solution contains 0.01 molar amount of Ag plus and 0.05 molar amount of Cl minus. Now the next thing that we need to do is this. Ag plus will combine with Cl minus to form AgCl. The amount chosen is 0.01, this is 0.05. Now I told you that almost all amount of Ag plus will combine. That means what would be left out? 0.04 will be left out. And how much of Ag plus will be left? Very small. And let's say that be X. ठीक है? अब आपने ये जो entities present है solution में, this is what is present in the solution. The ionic product of this should be equal to this. Whatever is present in the solution should be equal to this. So 10 raised to minus 10 should be equal to X times 0.04. Why I'm doing this is because I know for a fact that the ionic product in the solution, if I calculate the product of these two, it is obviously very large as compared to this. So that means maximum precipitation will take place, and when the equilibrium will be established, the equilibrium will have this much amount of unreacted Cl minus and some X amount of unprecipitated Ag plus. The product of that should be equal to 10 raised to minus 10. तो कितना हो जाएगा ये? This would be equal to 100 by 4 times 10 raised to minus 10 is equal to X. That is 25 times 10 raised to minus 10, or I will say 2.5 times 10 raised to minus 9. The right answer to this question should be 2.5 times 10 raised to minus. This is how this question would be solved. Ever you see a question where you have been asked the remaining amount of this, you should proceed like this. Okay? Let's move ahead. Next question is this. थोड़ा वर्डी क्वेश्चन है, थोड़ा लंबा क्वेश्चन लग रहा है, लेकिन बहुत डिफिकल्ट नहीं है. इसको समझते पहले. A 1.025 gram sample containing weak acid HX is dissolved in 60 ml of water titrated with NaOH. So weak acid, strong base. Whenever weak acid, strong base is there, this should flash in your mind that something like a buffer will exist, an acid buffer will exist, and salt hydrolysis giving rise to a basic solution will exist. ये दोनों चीजें होंगी. Okay. How would I identify that when to apply buffer equation? When the amount of base is less than, when base is the limiting reagent. मतलब base का amount acid के amount से कम होना चाहिए. When base amount and acid amount will become equal in terms of moles, they'll become equal, complete neutralization will take place, and that instant you will apply the salt hydrolysis equation, because at that instant only salt will be present. So any point before equivalence will be buffer equation, at equivalence hydrolysis. Okay? Let's move ahead. When half of the acid is neutralized, so half acid neutralized का मतलब ये हो गया कि I have to use buffer equation. Half acid neutralized, that means some amount of acid is still present in the medium and some salt is present. So both of them will constitute a buffer. Equivalence point is 9, so that justifies my statement. So we start with this idea that at half equivalence, let's say the acid is HX plus NaOH, it will result in the formation of NaX plus H2O. Okay, half equivalence. So what it means as half equivalence, half of this is neutralized, that means this is the limiting reagent. Half of this is neutralized, this is the limiting reagent. I will use the buffer equation. pH is equal to pKa plus log of salt by acid. What is the meaning of half equivalence? When the amount of this is neutralized to half of it. So if there are 100 millimoles or 100 moles of this, 50 are neutralized and 50 of this will be formed. So the amount of NaX and acid which will be present in the solution will be equal. So ये cancel हो जाएगा. Log 1 will become equal to 0. So pKa will be equal to pH. What is the pH over here? 5. So our pKa value for this is 5. Next part of the question. Equivalence point is 9. How would I identify what is the equation for equivalence point? Now when it is 9, that means it is more than 7. ठीक है? इतना तो मालूम है आपको. So at that instant, pH will be calculated in this way. That's 7 plus pKa by 2. Weaker component क्या है? Acid. Acid का what decides the dissociation of an acid? pKa plus log C by 2. Okay. pH is given as 9. I will incorporate these values. So 7 plus pK is 5, that becomes 2.5 plus log C by 2. So this will become minus 0.5 times 2 is equal to log C. So C turns out to be 10 raised to minus 1. So हमारा result क्या निकला? Concentration of salt is 10 raised to minus 1. Now tell me something, if the concentration of salt is 10 raised to minus 1, the concentration of acid should also be 10 raised to 1. The concentration of acid, I mean the millimoles of acid should be 10 raised to minus 1. The millimoles of base should also be 10 raised to minus 1. तभी जाके equivalence point पे ये salt 10 raised to minus 1 बनेगा. अगर इन दोनों का amount equal होगा, then only this will be formed. ऐसा नहीं होता है कि this is 10 raised to minus 1, this is 10 raised to minus 1, this will become 2 into 10 raised to minus 1. So if this is 10 raised to minus 1, this has to be 10 raised to minus 1. So with this idea in mind, what we will do is, so concentration of NaOH will be 10 raised to minus 1. Now, what is the molarity of NaOH? 0.25. 0.25 का कितना वॉल्यूम आप लेंगे कि ये 0.1 हो जाए, ये मुझे मालूम नहीं है. लेट्स से दैट बी V. इतना मिलीमोल्स आपने लिया, but this millimole is present in the total volume which is 60 plus V. Total millimoles of NaOH which will be added is 0.25 times V, but these number of millimoles are present in 60 plus V volume because 60 ml water पहले से present है. So this will be 0.1 times 60, 0.1 times 60 plus V is equal to 0.25 V, that will become 6 plus 0.1 V, 0.25 V. So this will be equal to 6 is equal to 0.15 V. So V turns out to be equal to 40 ml. This is the amount of NaOH that you need to use. This is the amount of NaOH that you need to use. ये 40 ml होना चाहिए. So what is the number of millimoles of NaOH? Number of millimoles of NaOH turn out to be 0.25 times 40, 25 for 100, 10 millimoles, that is 0.1 mole. If I am using 0.1 mole of NaOH, then 0.1 mole of acid should also be used. Always remember, molarities may be different, but moles have to be equal for complete neutralization. A lot of people make a mistake over here. They consider that the molarities have to be equal. No, the moles have to be equal. So the number of moles of NaOH is 0.1. The number of moles of HX should also be 0.1. 0.1 mole होगा तो weight कितना होगा? 0.1 times 82, that is 10 millimole. I'm very sorry, 10 millimole is not the same as 0.1. 10 millimole would be equal to 10 times 10 raised to minus 3, that is 0.01 mole. So this should be 0.01 and it will be 0.82 grams. So HX का amount 0.8 grams अगर आपने लिया, this will react to give this result 5 at half equivalence and 9 at equivalence. How much amount, however, have you taken? 1.025. So percentage of HX is 0.82 by 1.025. This is almost equal to 80%. The right answer should be B. Okay, a little lengthy a question, however a lot of concepts are directly connected to each other. So we start backward, we take both hydrolysis, buffer, amount of NaOH. From volume of NaOH, we calculate the number of moles of NaOH, relate the number of moles to, so a number of steps have to be gone in the backward direction so as to get this answer. Okay, a slightly advanced question, but takes through the whole topic. Next question. Next question is this. It's a very simple question. For the reaction at 300 Kelvin, the average molecular weight of the equilibrium mixture is 83. Okay, average molecular weight is 83. If atomic weight of ABC are 160 and 40 grams, then the number of moles of C present at equilibrium in a reaction is starting with 10 moles of A. Now, so much of data is given. So what we need to utilize? पहले ये देखते हैं कि what will be the equation that we can write for this. So A changes to B plus C. 10 times 1 minus alpha, this will be 10 alpha, this will be 10 alpha. Can I write this? 10 moles of A से start कर रहे हैं. I will get this relation. Now if I try to write using vapor density, याद है vapor density क्या होता है? Vapor density याद रखो, vapor density is inversely proportional to the number of moles. Inversely proportional. Okay, utilizing this idea, what would have been the initial vapor density? अगर if इसका weight 100 grams है, then vapor density would be equal to 50. And if the total weight of the mixture is 83, then the vapor density would be equal to 41.5. So if I utilize this relation, then 50 by 41.5 should be equal to whatever amount of substance is present at the end. This should be inversely proportional. So initial total amount कितना present है at equilibrium 10 times 1 plus alpha, और आपने initially कितना लिया था 10, so 10 times 1 plus alpha by 10. So for 10 moles vapor density is 50, for 41.5 vapor density is this 10 and 10 gets cancelled. I will get the value of alpha. So alpha will turn out to be, if you calculate alpha this will be equal to 1.2. 50 by 41.5 is 1.2. You will get this result as 0.2. Alpha निकल गया तो C निकालना कितना easy है. 10C is the amount of 10 alpha is the amount of C. So 10 times 0.2 turns out to be 2. The right answer to this question, number of moles of C 2 हो जाएगा. Integer type question है, आपका आंसर 2 आना चाहिए. Is this clear? This is how you should solve the question. Okay, let's move ahead. This question, multi-option correct question. However, a very important catch over here is volume percentage is given. Volume percentage और ना pressure percentage में कोई difference ऐसा नहीं है यार. एक closed container में जितना volume उसने occupy किया होगा, जितना volume percentage रहेगा, the same would be the pressure percentage. That means the total pressure of the mixture at equilibrium if is X and the volume percentage is given, what you do is you take that whatever X is the total pressure times the volume percent, you will get the pressure exerted by that particular gas. So pure PCl5 was introduced in equilibrium at 247 and 2 atmospheric pressure. At equilibrium, the equilibrium mixture contains 40% by volume of Cl2. Okay, so I need to identify Kp. Kp will be equal to Kp will be equal to pressure due to PCl3, pressure due to Cl2, pressure due to PCl5. Okay. Okay. At Kp for the equilibrium is 1.6. Let's try to identify this. So 40% of 2. This is the pressure of Cl2. 0.8. Okay, this turns out to be 0.8. So if this is 0.8, this has to be 0.8. Okay, if this is 0.8, this has to be 0.8. What would this be equal to? ये 40% है, ये भी 40% रहेगा, ये 20% रहेगा. Okay, so if 40% is 0.8, then what would 20% be equal to? 20% will be equal to 0.4. So our answer will be how much? 0.8 times 0.8 1.6. First statement is correct. You can identify Kc by using this relation. Kp equals to Kc RT to the power delta N. What is the value of delta N? Delta N is equal to 1. So Kp, which is 1.6, Kc will become Kc will become 1.6 by 0.0821 times 247. So 247 plus 273, that turns out to be 520. Put 1. If you calculate this value, this will come as to be 0.037. I did the calculation, तो मैंने calculation किया है, इसलिए 0.037 ये नहीं आता है, ये आएगा, ठीक है. Next, addition of inert gas to the equilibrium mixture at constant pressure increases the number of moles of PCl3. Now, how do we solve an inert gas question? Remember this, I will always use this relation, Kp equals to products by reactant times RT by V, or you can use total pressure by summation n to the power delta n. Try to use this equation. This is a very important shortcut. Try to use this equation. P represents total pressure, products, reactants, and summation n represents total number of moles. Now delta n is positive. So this is positive, ye positive hai. So this part will remain like this. If I increase this, to keep this constant, don't I have to increase products? अब देख लीजिए, if I increase the denominator, to keep this constant I have to increase the numerator. Okay, if I increase the numerator, the reaction is going in the forward direction. Products increase होने का मतलब reaction is going in the forward direction. So what is the third statement? Addition of inert gas to equilibrium at constant pressure. If this is constant, the number of moles of results in an increase in number of moles of PCl3, which is correct. Forward move कर रहा है. Next, increase in pressure increases the number of moles of Cl2. If I increase the pressure, the reaction will go in the backward direction. If it goes in the backward direction, the amount of Cl2 will decrease. This is incorrect. The right answer to this question should be A and C. Okay? Let's move on to the next question. Next question is this. Again a question on buffer. Simple question. 6 ml of 0.1 molar acetic acid when mixed with x ml of 0.1 molar NaOH, the pH of the resulting buffer was found to be 5.04. What is the value of x? बहुत सिंपल सा सवाल है, बहुत इजी सा सवाल है. कैसे करना है? बफर दे दिया गया, इसका मतलब this amount has to be lesser than the amount of acetic acid, and the amount is measured in terms of moles, not molarity. Remember this, moles, not molarity. So what we would do is, we'll write the equation like this: CH3COH plus NaOH changes to CH3CONa plus H2. ये होना है 6 ml of 0.1, 6 times 0.1, x times 0.1. तुमने लिया initially 0 and this is 0. This is 6, this is 0.1x. What would this amount be equal to? 0.1x ही होना चाहिए. Whatever is the limiting reagent, उतना ही आपका बनेगा salt. But what will be the amount of this left out? 6 minus 0.1x. The amount left out would be 6 minus 0.1x. Okay, so this is equal to this, this is equal to this. The amount of substance left, this will become 0. This will be 0.1x. This will be 0.1x. Okay, now we incorporate this result in the buffer equation. So buffer equation क्या होता है? The buffer equation is this: pH is equal to pKa. pH is equal to pKa plus log of salt by acid. Log of salt by acid. pH is given as 5.04. pKa is 4.74 plus log of, what is the amount of salt? 0.1x. What is the amount of acid which is left out? 6 minus 0.1x. Okay, so this will be 0.3 is equal to log of 0.1x by 6 minus 0.1x. Anti-log of 0.3 is 2. Okay, anti-log of 0.3 is 2. So 2 is equal to 0.1x 6 minus 0.1x, so that is 12 minus 0.2x is equal to 0.1x, or 12 is equal to 0.3x, or x will be equal to 40. So ये हो जाएगा आपका आंसर 40 ml. This x will be equal to 40 ml. Okay, they can ask you the question in number of ways. They can ask you it in the multi-option correct question. They can ask you the final concentration of salt. But when you are calculating the final concentration of salt, the final concentration of salt will be the millimoles of salt plus millimoles of salt divided by the total volume of the solution. The total volume of the solution will be 40 plus 6, 46 ml. Okay. Is this clear? Let's move on to the next question. The next question is very interesting. So let's look at this question. What is the pH of a solution of 0.1 molar Na3PO4? Now, when Na3PO4 is taken, PO4 3 minus is a very special type of ion because it is produced from a polyprotic acid, that is H3PO4. When such a solution is given, try not to jump into the conclusion by choosing one of the Ka values or choosing the largest Ka value. Don't do that. Okay, just first understand the logic behind going about for anything like that. So my point is, the usual equation that we write for identifying this is a salt. So salt hydrolysis is salt of weak acid and a strong base, because this is formed using combination of H3PO4 plus NaOH. So what we write is pKa by 2 plus log C by 2. Now which Ka value should I be using? Because there are three different Ka values. Why there is a problem, I will tell you, is that PO4 3 minus can react in three different ways. It can react with 1 mole of H2O to produce HPO4 2 minus plus OH minus. It can react with 2 moles of H2O. दो से भी तो रिएक्ट कर सकता है ना, एक से रिएक्ट कर रहा है, दो से भी रिएक्ट कर सकता है, to produce H2PO4 minus plus 2OH minus. It can also react with 3 H3PO4 plus 3OH minus. Now most of the students ये सोचेंगे कि 3OH minus produce हो रहा है, so I should take this equilibrium into account. This equilibrium into account. Now let me explain this to you, that how this works. When I perform hydrolysis, that equilibrium will be taken into account, which will have the highest equilibrium constant. ये सारी equilibriums हैं. So ionic equilibrium में जिसका ज़्यादा equilibrium constant रहेगा उसको priority दी जाएगी. What is the equilibrium constant for this? How do I calculate? I will do a very simple calculation. What I'll do is, I'll take HPO4 2 minus by times OH minus by PO4 3 minus H2O and multiply this with H plus. डिनोमिनेटर न्यूमरेटर को मल्टीप्लाई कर देते हैं H प्लस से. इसको समझ लीजिए, मैं आपको समझा रहा हूं. So if I rearrange this equation, HPO4 2 minus times H plus by PO4 3 minus times H plus OH minus H2O, this doesn't it look like Ka3? Doesn't it? Sorry. Doesn't it look like Ka3? Third dissociation. This looks like Ka3, rather inverse of Ka3. Okay, inverse of Ka3. 1 by Ka3 looks like 1 by Ka3, because Ka3 क्या होगा? H2PO4 minus changes to PO4 3 minus plus H plus. इनवर्स ऑफ दैट व्हाट इज दिस KW, सो हम लिखेंगे क्या KW by KA3, I'll write this. Okay, so if this is understood, I will write for this KH is KW by KA3. For this I will write KH is equal to, देखो दो OH माइनस प्रोड्यूस हो रहे हैं, 2 OH माइनस को कंपनसेट करने के लिए और न्यूट्रलाइज करने के लिए 2 H प्लस आयन चाहिए, सो H प्लस स्क्वायर हो जाएगा, सो OH माइनस स्क्वायर H प्लस स्क्वायर, ठीक है, दैट विल बी KW स्क्वायर. And what is the relation between PO4 3 minus and H2PO4 minus? H2PO4 minus will dissociate once to produce HPO4 2 minus. HPO4 2 minus will dissociate again to form PO4 3 minus. That means I am taking the second and the third dissociation. Don't you think? H2PO4 minus से यहां तक जाने के लिए हमें 2 बार dissociation करना होगा, and that will be second dissociation and the third dissociation. तो second dissociation third dissociation को multiply करके यहां पे हम रखेंगे KA2 times KA3. Similarly अब थर्ड का बता दीजिए क्या हो जाएगा KH, so it will be 3OH minus, so KW cube by KA1 times KA2 times KA3, क्योंकि H3PO4 से PO4 3 minus अगर मुझे जाना है, if I have to go from H3PO4 to PO4 3 minus, I will have to dissociate H3PO4 thrice, so I will all use A1 second third dissociation. So let's try to calculate what is the KH value. The KH value for this will be equal to 10 raised to minus 14 और KA3 कितना 10 raised to minus 12, तो ये हो जा रहा है 10 raised to minus 2. ये कितना होगा 10 raised to minus 28 by 10 raised to 20, 10 raised to minus 8. This will be 10 raised to minus 42, 10 raised to minus 42 by 10 raised to minus 3, 10 raised to minus 10 raised to 10 raised to minus 23, that is 10 raised to minus 19. तो एक बात बताओ, which equilibrium is most favored? जहां पे एक OH माइनस निकल रहा है क्या कि जहां पे 3 OH माइनस निकल रहे हैं? Which equilibrium is most favored? This one. तो यहां पे आप क्या which K value should you be using? You will not use the sum of these three. You will not use the last two because they look larger. You will use the last one, KA3, because यहाँ पे KA3 utilize करके we are getting the largest value of KH. So in this scenario, this will be KA3, and so the pH will become 7. KA3 is 12, pK3 is 12, so this will be 6 plus log of 0.1 by 2, that will be 7 plus 6 minus 1.3, log of 0.1 by 2, so our pH will turn out to be equal to 13 minus 1.3, that will be 11.7. Okay, is this clear? So remember this logic. I have elaborated this just to make you understand a very, very important and beautiful concept. Similarly, if it is Na2CO3, then you will take the last dissociation, okay, Ka2. If it is NaHCO3, HCO3 turns out to be amphiprotic, so you will take Ka1 plus pK1 plus pK2 by 2. ठीक है? ठीक है? Let's move on to the next question. Okay, next, what is the pH of the solution? What is the pH of the solution for 4 moles of H3PO4, 2 moles of NaH2PO4, 3 moles of NaH2PO4, 2 moles of NaH2PO4, 1 mole of Na3PO4. Sorry, this has to be Na2HPO4. Please make a correction. This has to be Na2HPO4, okay, and 1 mole of Na3PO4. In this case, you have been given a weak acid along with the salts that it can produce when it reacts with NaOH. To solve such a question, I will always use the concept of acids and base rather than using hydrolysis or anything right away in the beginning. If I write H3PO4 and form these ions, H2PO4 minus plus H plus, H2PO4 minus changes to HPO4 2 minus plus H plus, HPO4 2 minus changes to PO4 3 minus plus H plus. ठीक है, हमारे पास ये 3 इक्वेशन है. Now if you look at the conjugate acid base pair, which is the strongest acid? Strongest acid is this one. What is the strongest base among all the given ions which are present? This one. Now if PO4 3 minus and H3PO4 are simultaneously present in the medium, they will react with each other. Acid base reaction will take place. Okay? We follow that trend. So we start with 4 moles of this and 3 moles of this. What would be the reaction? How would I write that? I will just reverse this third equation, add it to the first one. So if I do that, I will get H3PO4 plus PO4 3 minus will give H2PO4 minus plus HPO4 2 minus. It's very simple. So ये 4 लिया हमने, ये 3 लिया. This will be completely consumed, isn't it? This will be, sorry, I've taken 1. I've taken 1. I've taken 1. This will be completely consumed. 3 of this will be left out, and this will be 1 of this, and 1 of this will be formed. Okay, 1 of new moles is formed. Now let's calculate the total amounts at this juncture. H3PO4 is 3, H2PO4 minus is 3 plus 1 newly formed 4, HPO4 2 minus is 2 plus newly formed 1, that is 3. Okay, that's it. Next, this the strongest acid is still present. The strongest acid is still present. So H3PO4 will now react with the next strongest base, that is HPO4 2 minus. Okay, देखते हैं क्या बनता है. I take the first equation and the second equation and add it together. Reverse the second equation, add it together. So I will get 2 moles of H2PO4 minus, can I write this? If I add the first and the second by reversing the second, H3PO4, HPO4 2 minus, it will give 2 moles of 2H2PO4 minus. How much of this is taken? 3. ये कितना है? 3. This was initially 4. This will become 0, this will become 0, and this will become 3 plus 3, 6. Sorry, 3 moles of this, 3 moles of this will react to produce 6 moles of this. So 6 plus 4, 10. तो टोटल हमारे पास सॉल्यूशन में क्या प्रेजेंट है अभी? दिस इज कंप्लीटली कंज्यूम्ड, दिस इज कंज्यूम्ड, सो दिस इज गॉन, this is gone, this is gone. What is left out is 10 moles of NaH2PO4. NaH2PO4. If that is present in the solution, how should we calculate the pH of such a solution? H2PO4 minus will behave as a amphiprotic ion. Amphiprotic means it can give out H plus, it can take up H plus. in this scenario, always remember H2PO4 minus, whenever you take amphiprotic like a Zwitter ion, it be like Zwitter ion isoelectric point, that was also amphiprotic. So uska bhi concept yahi se aata hai. So you will take pKa of the pKa of formation of that and pKa of dissociation of that by 2. So formation H2PO4 minus has been formed using pKa1. H2PO4 minus is dissociating using pKa2. So pKa1 value is 3 and 8, 11 by 2, that is 5.5. The pH of the solution will be 5.5. Okay? So this is the answer to this question. Let's take this question as well. What is the pH of the solution which contains 1 mole each of H3PO4, NaH2PO4 and Na3PO4? 1 mole each of only these three. 3 present hai, not 4. So how do we solve the question? H3PO4 changes to H2PO4 minus, H2PO4 minus changes to HPO4 2 minus, HPO4 2 minus changes to PO4 3 minus, H plus ion being common in all of them, I'm not writing that. So 1 mole each आपने लिया है, this is 1 mole. आपने H2PO4 minus भी 1 mole लिया है, and you have taken PO4 3 minus also 1 mole. Okay, so now 1 mole of this and 1 mole of this will react with each other. ये दोनों react करेंगे. If both of them react with each other, what will be formed? H3PO4 plus PO4 3 minus. If they react, it will form HPO4 2 minus plus H2PO4 minus. 1 mole of this, 1 mole of this will be formed. Okay, 1 mole of this, 1 1 था, ये 0 0 हो जाएगा, and this will be 1 and this will be 1. So this is completely gone. This is completely gone. PO4 3 minus is gone. So what was the initial amount of H2PO4 minus taken? 1 mole. So 1 mole plus 1 mole newly formed. So that becomes a total of 2 moles, and this is 1. HPO4. So this is 2 mole, this is 1 mole. What is the relation between these two? They are conjugate acid-base pair. A conjugate acid-base pair, if is present within the solution, like acetic acid and sodium acetate is present. Acetic acid and acetate is present in the solution. What does it constitute? It constitutes a buffer. It constitutes a buffer. So when I calculate the pH of this solution, pH will be pKa. Which pKa I will take? H2PO4 minus is associating pKa2 plus log of, what is the conjugate base or the salt? This will be the salt, this will be the acid, 1 by 2. pK is 8 plus 8 minus 0.3, that is 7.7. This will be the right answer to this question. Please do remember that when you are mixing acids with its salts and all, you have to always utilize this concept of solving the question. Okay? So let's move on to, let's see if there are any more questions. No. So with this, we finished today's session, and I hope you have understood how to go about certain tricky areas of ionic equilibrium and chemical equilibrium. Try to practice more questions on buffers, try to practice more questions on salt hydrolysis, so that you do not miss out on these things. Okay, so it is important that you proceed like this. Okay, so I wish you all the very best, and we'll meet each other in another session of JEE Advanced Aspire, and until then, keep practicing and shine on.